In Lab 1 of Physics 2212, we observed interactions with charged pieces of tape. The purpose of this experiment is to prepare two pieces of charged tape and observe their interactions with other objects. The charge of the tape can then be determined and a computational model is created using glow scripts to compare the two charges. The charge of the tape was determined to be positive at 9.56 E negative 9 coulombs, and the tape is deficient of 5.975 E10 electrons. Important concepts used in this experiment are Newton's second law, which was used to calculate force, and Coulomb's law, which was used to determine the charge on each piece of tape. In this experiment, a piece of tape is charged by taping it onto another piece of tape and removing it. The tape is then put near other objects to observe their interaction. When placed near my hand and a pen, the tape was attracted. The pen was rubbed on a shirt, which removed electrons and caused the pen to be negatively charged. Since the tape was attracted to it, we can conclude that it is positively charged. When another charged piece of tape was suspended and interacted with the initial charged piece of tape, they repelled. In the interaction with the suspended tape, the system is the suspended tape, and the surroundings are the held tape and everything else. It is assumed that the tape acts as a point charge and both pieces have equal charge. Air resistance is also ignored. The initial conditions are two pieces of neutral tape along with a third piece taped to a table. Here is the data on the pieces of tape. Using a ruler, the length of the tape is 0.21 meters and the width is 0.02 meters. Using those measurements, the surface area can be determined, which is 0.0042 meters squared. By following the equation shown, the surface area was used to determine the number of atoms in the tape, which is 4.2 E17 atoms. Since we know that 1 meter of tape is 0.001 kilograms, we can calculate the mass of the tape as 0.21 meters, which ends up being 0.00021 kilograms. By multiplying this mass by 9.8, or the force of gravity, we can determine the gravitational force. Since acceleration is zero, gravitational force and electric force are equal. A ruler was used to measure the distance between the pieces of tape when they first started to repel, which was 0.02 meters. This distance can be used as the r vector in the shown equation. We previously determined the gravitational force and can calculate the charge of the tape, which is 9.56 E negative 9 coulombs. The number of deficient electrons can be determined by dividing the charge by 1.6 E negative 19 coulombs, which gets us 5.975 E10 deficient electrons. Here is my computational model for the point charge model. As you can see in the code, measured values and equations were added to create the model. The magnitude and deficiency of electrons is very similar to their actual values. Here is my computational model for the line charge model. The mass used is the measured value and the charge is from the previous model. The model determined that the electric force is 3.51353 E negative 4 newtons, and by using the pictured formula, the charge of the tape can be calculated, which ended up being 3.952 E negative 9 coulombs. When comparing the two computational models with my experimental results, the point charge model is much more similar. Possible errors include inaccurate measurements of the tape and the distance between the tapes, which would have affected calculations for charge. There also may have been routing errors. If the charges of electrons and protons were reversed, there would not be much change in the observations of the lab. The positively charged tape would become negatively charged, but the other objects would also have their charges reversed. The tape would still be attracted to the now positively charged pen and would still repel the other negatively charged tape. The charge from the line charge model was lower than the charge from the point charge model. The charge from the line charge model is likely to be more accurate as the charge is more evenly distributed.